On to part B of example 3, and I want us to note a couple things here. One is that our A is equal to minus 3/2. So remember, not only is this then going to cause a vertical stretch, which maybe I'll fill in right now. And by fill in, I mean write in the tick marks for it. Let's say that looks about right. And this is 3/2 and minus 3/2. And before I actually wrote in my tick marks, I should have also pointed out to us that D was equal to 0, so there was no vertical shift. Okay. Next. Now, we don't actually want to be thinking about cotangent of x here. We actually want to be thinking about minus cotangent of x. And let me remind you what cotangent of x looks like, and then we'll look at minus cotangent of x. So here's cotangent. Not quite. Here it is. And you can see it's decreasing, right? So if we were looking at minus cotangent, it would look a lot like this, except for it would be increasing, okay, right? Instead of the y value here being +1, it would be -1. This would still be 0, and this one would become +1. Let's go down and see what this looks like. There we are. So here is minus cotangent of x. Now it looks really very similar to tangent of x, other than the vertical asymptotes are in different places. All right. Next, we need to think about the period and the phase shift and the spacing. Let's start off maybe with the period. So the period, again, it's not 2 pi over b for tangent and cotangent, it's just pi over b. So pi over b for us is just going to be pi over 2. And then that would mean the spacing is that divided by 4. And if you divide pi over 2 by 4, you'll get pi over 8. And then there's one last thing, the phase shift. Which is given by the formula C over B. Or if you want to factor, you can factor in here. Either one of those work. Okay. But our phase shift, C over B, well, our C, right, it's always the opposite sign. So minus pi over 2. And then all over B, which is 2. So this is minus pi over 4. All right, and now is what this means is that vertical asymptote that we have here at x equals 0, well, that's now at minus pi over 4. Let's go ahead and move that vertical asymptote over to minus pi over 4, and then we'll start writing in our tick marks, or the rest of them. So minus pi over 4. Let's say that that is right here. And I wrote this kind of far over to the left because our spacing is by pi over 8. So I need to be able to fit in one more point here. This would be minus pi over 8. And I'm going to do exactly like I said. At minus pi over 4, this is where the asymptote is now, because we've scooted our graph pi over 4 units to the left. So that part's taken care of. Let's start counting by pi over 8. If you add another pi over 8, you end up at 0. Add another pi over 8. We end up at pi over 8. And I think I might need to, actually that looked about right. Pi over 8. And then the next one would be pi over 4. and then we'd have 3 pi over 8, and then 4 pi over 8, which is pi over 2. All right, and then 5 pi over 8. And actually, I'll stop counting here and we'll fill in more if we need to. So if I were to count, so 1, and I'm counting from this vertical asymptote. 1, 2, 3, 4. Once I hit that 4th quarter point, that's where our next asymptote is. So it looks like we only have enough for 1.5 periods so far. So we'll need a couple more tick marks here in a minute. But I think we can fill in some of this right now. So if we look back at this shape here, again, you can see that the center of the shape happens directly in between two asymptotes. Okay? And so since we haven't been scooted up at all, and directly in between these two asymptotes is at x equals 0, we're going to put a point right here. And then this is supposed to be increasing. So if I move to the right, to my next quarter point, I should be up to A. And if I move one to the left, I should actually be going down. There we go. And then we can connect the dots there. There we go. All right, and then, like I said, we need a couple more quarter points here. So this was 4 pi over 8. So the next one should be 5 pi over 8. And then we should hit 6 pi over 8, which is 3 pi over 4. And that is our last asymptote that we're going to graph. Because we're asked to do 2 periods of this function. All right, and again, directly in between our two asymptotes should be the center of the shape. If D was, say, 1, I would have had to scoot this point up 1 unit. If D was equal to -1, I'd have to scoot it down a unit. But we don't have that vertical shift, so we're right there. And then again, at the next quarter point, we should be up to whatever A was, so that 3/2, or the absolute value of it. And then at 3 pi over 8, we should be down to -3 pi over 2. And then we'll just connect the dots. In our next example, we're going to actually try, and this is not our next one. Let me scoot up to the right spot right here. Yeah. We're going to try and find the equation of the function that's already been graphed. Okay. And so the first thing that I would note is this looks more closely to what function? Tangent or cotangent? And you might already see the word tangent in the directions, but you want to be able to recognize that, hey, tangent would be the better option here because I can see that we do not have a vertical asymptote on the x-axis, and I can see that I have asymptotes in equidistant from the y-axis on both sides, over here and over here. Okay. This just reminds me a lot of tangent. Okay. Now, that being said, let's get started. Let's try and write this. And I have tangent actually right here. Okay. And you can see it does look quite a bit alike. Okay. But you can see that the period's going to be a little bit different. Maybe the amplitude as well. Again, we actually don't call it the amplitude, but you can see here on this one, these were supposed to be 1 and minus 1. And you can see on this one, these important points are actually at 6 and minus 6. And unfortunately, you can't tell for sure, but this is halfway in between 0 and 3 pi over 2. So yeah, those are our important points. So that means that for us, A is going to equal 6. Let's go ahead and write that in. If A equals 6, that's a start. And also note, I'll maybe circle it now, this point right here, and it's directly on the origin, right? And you can see the same thing could be said here. The very center of this shape is at the origin. Okay, we haven't been shifted up, we haven't been shifted down, we haven't been shifted left, we haven't been shifted right. So D here is 0, and actually we can say that C is also 0 because it hasn't been shifted left or right. So I'm going to say actually C equals D equals 0. So there's no, again, no shift left or right or up and down. All right, and then there's one last piece here. We have B. So we're going to need to try and look at the period of this. So the easiest way to find the period of a graphed tangent or cotangent function is actually to subtract the x value that corresponds to 2 consecutive asymptotes. And you can see this one here is actually not very easy to read, so maybe we'll use this other one. We'll use this one and this one. Let's do that. So 9 pi over 2 minus 3 pi over 2 is equal to 6 pi over 2, which is 3 pi. And so this is our period. Okay, and you might be wondering, well, why is this helpful? This didn't give us B, which is the last thing we have left to find. Okay, well, we know that the period is also given by pi over B, right? Pi over B should be equal to whatever the period is. And so if you solve for B here, we get 1/3. And so this is everything we need. We can actually finally write the answer now that we have all this information. So y equals, we have A is 6. We're using, again, tangent. B is 1/3. There's no C or D. All right, and so there it is.